Hi everyone, here we are continuing with our statistics class notes. We're on page 8. We are getting into chapter 2, which is called Picturing Variation with Graphs. So remember that word variation means looking at differences. So variation means differences. So we want to be able to visualize a data set and see what kind of differences we see in the data. The topics for the entire chapter include visualizing variation in numerical and categorical data. So remember, we have two types of data: numerical data where arithmetic makes sense, and categorical data where really arithmetic doesn't make sense. It can be numbers, but it doesn't make sense. Categorical data is usually things like eye color, hair color, even zip codes, something like that. Zip codes are numbers, but you really can't do arithmetic with them. And then we want to learn how to summarize the important features in both of these kinds of distributions, numerical and categorical distributions. So the first two sections, sections 2.1 and 2.2, we're going to work with numerical data first. In section 2.1, we are visualizing variation in numerical data. Remember, that's again data that are numbers, that arithmetic makes sense. Things that can be measured, height, length, those kinds of things. Okay, so the topics are exploring distributions of numerical data, and then we're going to learn about 3 different kinds of graphs that we can draw. These are dot plots, histograms, and then there are frequency and relative frequency histograms, and then stem plots. First of all, though, we need to understand and ask a question. What is the distribution of a sample? So remember, we have a sample of data that's supposed to represent some kind of population. We need to understand what the distribution of a sample is. So recall that any collection of data will have variation within the data. We'll see differences in the data. An important tool for organizing and evaluating the variation in the data that we see is called the distribution of the sample. There are 3 main components of a numerical distribution that we want to be able to describe. We want to understand they are the following. So shape, center, and spread. I'll probably say those 3 a lot together over time. Shape, center, spread. So shape says, what does it look like visually? The center is, okay, what's the typical value? If I'm kind of looking at my data, what's in the middle? What's the center? And then the spread is, how does it look like it's spread out? How far apart are the data points? And when we say that, we mean horizontally. So you're looking at a distribution. Remember, when you're looking at things with graphs, usually you think of the horizontal axis as like the x-axis. The x-axis are all our data points, and then the y-axis tells us how many of those data points we have. Okay, we'll see that more in a bit. Okay, so in example 11, we're going to look at a very simple distribution. So this is some raw data on number of games played by a sample of professional female soccer players during a given season. And I've sorted them in ascending order already, so the smallest to the largest. I actually found this data in StatCrunch. If you're interested, you can click on it and get the data yourself. Note that the distributions record all observed data values. So when I'm looking at a distribution of data values, I'm actually going to look at all of them. I'm not throwing anything out. And I'm trying to see patterns in the raw data, which can be difficult when I'm just looking at numbers like this. So one of the first things we can do is construct what's called a frequency table. In a frequency table, the distribution of data can be organized, and a frequency table lists all the data values with their counts. So one of the first steps in organize is actually sort it. So we're not learning how to sort in this class, but I have this data sorted from lowest to highest already. But we can see things like, hey, there were 3 soccer players that only played 1 game. There was 1 that played 2, 1 that played 5, 1 that played 6, 1 that played 7, etc. Until we get to 10, there were 2 that played 10 games. There were 1, 2, 3, 4 that played 11 games. And you can see that this is how I filled in this frequency table. Right? List all the different values that showed up. There was 1 game played, 2 games played, 5 games played, 6 games played, and then underneath them, the frequency, sometimes people will call it the count, is where you count up how many of those data points showed up in your data set. So the number 1, the 1 soccer game played, was showed up 3 times. There were 3 different female soccer players that played only 1 game, etc. And you can go through the rest of it and fill out the frequency table.